This morning, I went through the 103 assignment and looked for some common errors that people were making. You might have different problems that appear on your quiz, but they should all have the same skills. So I tried to find a few problems that we could go over, make sure that you understand them and you can make some corrections. And that way you can earn full credit for the 103 assignment and you can, learn from those mistakes so that when we get to our unit test, we don't make those same mistakes. So the first type of problem was one that used substitution. And I know this is a good substitution problem because you can see here, it already just has x equals. You might have a problem that says y equals. But if you get a problem where it's already just x equals something or y equals, that's a great substitution problem. All we're going to do is we're going to now take this value for x, y plus 4, and everywhere I see x, I can write that in. So I'm going to do y plus 4 instead of x plus y equals 6. Y plus y is 2y. Subtract my 4 from both sides, do those inverse operations, and then divide by 2. And we end up with y equaling 1. All right, so now once you know what y is, I can go back and I can solve for x. So I'm going to look at this second equation here, because it already just says x equals. So x equals, instead of writing y, I'll write 1, because I know that's what y is, plus 4. So x has to be 5, because 1 plus 4 is 5. Remember when we write it as a coordinate, even though we solved for y first, coordinates are always x comma y. So we're going to do 5, 1. Right, so our x goes first, our y goes second, 5 comma 1. I did see some people picking answers that were the reverse, meaning you were able to solve for the two numbers, but you weren't putting them into the right spot for the coordinate. X always goes first. So 5, 1 would be the solution here. The second type of problem that I saw as make some errors, I'm going to erase what's on the board, is a linear combination problem. We know that this is a good linear combination problem because I see it's written in standard form, meaning the x's are right on top of each other, the y's are right on top of each other, and those integer solutions are lined up as well. So for a linear combination, we want to try to find a number that we can, or find a term that can match on the top and the bottom equations. The only difference is we want one to be positive and one to be negative. It doesn't matter if you solve for x first or y first. So here, if I look at these two equations, I'm going to use the x's first, simply because they are there first. And I see I have negative 2x and 3x. And I want to think of a number that both 2 and 3 go into. And that, to me, pops up as 6. So I'm going to multiply the top equation by 3. Because 3 times 2 is 6. And I'm going to multiply the bottom equation by 2. Because 2 times 3x will get me 6x. And we distribute fully. So 3 times negative 2x is negative 6x. 3 times 6y, 18y. 3 times negative 38 is negative 114. And then I'm going to do the same thing on the bottom, but here I'm going to be multiplying by 2. 2 times 3x is 6x. 2 times negative 4y, because you take that sign in front of it, is negative 8y. 2 times 32 is 64. And for a linear combination, you add, and you may have called this the elimination method before, because the idea is that something on the top and something on the bottom will line up now and be able to be eliminated. Negative 6x plus 6x, oh, that can be eliminated because negative 6x plus 6x is 0. Then I move on to my next piece. I have 18y plus negative 8y, that's 10y, equals negative 114 plus 64. And that gets me negative 50. Now I do my inverse operations. And I get y equals negative 5. But that is not the full answer because we know we need to also solve for x. So I'm going to just take one of the two equations, it doesn't matter which one you use, and you're going to put in negative 5 for y. I'm going to try the second one simply because it has less negatives attached to it. So some people might not feel as comfortable with negatives, so I'm going to try using the second one. So 3x minus 4. Now instead of writing y, I'm going to put this negative 5 in. Equals 32. 3x negative 4 minus, times negative 5, that's a positive 20. And then I'm going to use my inverse operations, my two-step equation. 32 minus 20 is 12. Divide by the 3, that coefficient. And I get x equaling 4. Again, we want to make sure that we are paying attention to the fact that it has to be x comma y. So my final answer here would be 4 comma negative 5. All right, so that was a substitution problem and a linear combination. And I will just point out on the next slide, you can see these were some of the answers that people had picked. For the second one in particular, you can see that it was 4 negative 5, which is what we have here. But this person, and this person is not the only one, they flipped the order, and that's why it was incorrect. So you just want to make sure that you're paying attention to x coming first. The other piece I wanted to go over was our multiple choice strategy. And in 103, all of the problems were actually multiple choice. So you could have used this strategy for every problem, but I want to make sure that you understood how to use substitution in linear combination, because when we get to our unit test, not everything will be multiple choice, and you will have to type in what you get for your x or what you get for your y. So this one, when we had the 3 equations and we had 3 variables, I said you could check Module 103 if you really wanted to know the algebra behind it, or you could check our course notebook, and there were 2 videos there on how to solve a 3-variable, 3-equation system. But because we're early in the year, I wanted to just give you guys a little bit of a break with that, and I showed you on Friday how to use the multiple choice strategy. And that's basically just plugging and chugging. We're going to take our first possible answer, and we're going to substitute it into the first equation. The first one is going to be x, the second one's going to be y, and the third one is going to be z. It's going to follow alphabetical order. So this first equation here is going to become -4 plus 3 times 0 minus 12. And we're going to see, you can use a calculator to see how or what we get for that answer. And I get the answer of -16. -16 and 6 are not the same. So I know that this answer is wrong. I don't have to test it for any other equation, because if it doesn't work for one, then it's automatically incorrect. Remember, with the system, the variables must be the same for every equation. So I'm going to move on to the second equation, or the second answer choice. So I'm going to start with the first equation. -3 plus 3 times 5 minus 6. And again, you can put this straight into a calculator. If you're using a Desmos calculator or a scientific calculator, it will do the order of operations for you. And you should see that you get the answer of 6. So that one works. But just because it works for one doesn't mean we are done. When we are doing a system, you need to make sure that it works for all of the equations. So I'm going to go to the next one. And I have 4. Again, I'm going to put -3 in for x, minus 2. I'll put 5 in for y, plus 2 times 6. Going to put that into my calculator. 4 times -3 minus 2 times 5 plus 2 times 6. And I get -10, which is, again, what we want to get. So that one's good. And just for good measure, I'm going to make sure it works for the third one. And in this third one, you'll see that there isn't a y. There's just an x and a z. So we need to make sure that we're using the x and the z. So 6 times -3 plus 6 equals -18 plus 6 equals -12, which is exactly what the problem wants us to get to. So for your asynchronous time for math, if you did not get a 5 out of 5 on the 103 assignment, please use some time to go back, make some corrections. If you have questions about anything, please do just send me a message and I will do my best to try to answer that. But we are going to halt for today, new material, and we will all pick up with lesson 1.05 tomorrow. I will update the calendar to reflect that. But today, your main goal is to make sure 103 is completed and you've watched this video, made any corrections, and you can get a 5 out of 5 on the 103 assignment.